Good morning, rock stars. Today we are going to be continuing with our discussion on exponential functions by looking into what we uncovered yesterday involving percentages. So we're going to focus on examples today where we'll have exponential growth and decay, but we're going to be looking at the growth and decay factors that are actually percentage values. So our do now right here, suppose you deposit money into a savings account that receives 5% interest per year on the amount of money that's in the account for that year. This is literally what happens when you guys put money into a bank account. Assume that you deposit $400 into the account initially. And I want to know first, how much will the savings account increase by over the course of the year? So if we deposit $400, I just summarized it on this whiteboard. If we're depositing $400 into that savings account, I want to know first off, just how much money is my account going to increase over the course of the year? So first thing we need to do is really uncover, like, what does that 5% interest mean? And a lot of you guys, like pretty much every single one of you, was perfect at this yesterday. So, for example, I saw on Fatu's paper, she took that 5% and she made it into a decimal. And I know that Breezy, the way she did it was she took that 5% and she recalled that any percentage is out of 100. So she took that value and divided it by 100, and that converted it into a decimal, which gave you 0.05. I also saw a few of you use that little shortcut, like, okay, wherever my decimal point is, I know if I move it to the left 2 places, that also converts it into a decimal. So whatever method is easiest for you. But that was the first step that I saw in everyone's paper. They took that percentage and they made it into a decimal. But again, I want to know, how much money is it actually going to be increased by over the course of the year? So I know that Maria took $400 and she multiplied it by that percentage here, which was 0.5. And then it just became a straight calculator question, 400 times 0.05, which would give you $20. So over the course of the year, that savings account is going to increase by $20. That's what you just proved here. So now, part B, I want to know, okay, since it increased by $20, well, how much is there going to be in the account at the end of the year? So you know that it's increasing by $20. Well, how much is actually going to be in the account? And some of you are probably like, oh, that's very easy. I'm just going to take that 400 and add the 20, or just do it in your head. And we know that that's going to leave you with $420 in the account at the end of the year, okay? If you need to, go ahead, pause it, copy down what you need to, rewind, whatever you have to do. But that's pretty much what we discovered yesterday. You looked at an example of buying a pair of jeans and how much is that going to cost when I have a tax added on. We looked at when you went to a restaurant and you want to leave tip. Okay, how much is my cost going to be? We're going to be looking at, instead of getting in this situation, I'm going to say, okay, now we have that money in the account for another whole year. I don't want to keep adding 20 here. That's way too much work for us. We're past that point. We're mathematicians. So I want to look at, by what single number could we have multiplied 400 by in order to calculate our answer in part B? So I know the answer from part B is 420. But I no longer want to go ahead and take my initial value and add whatever that amount that it's increasing by every single time. That's so much work. So let's kind of break down what we did here. We took my initial value, which was $400. And we added it to 20. Well, let's go back and really uncover how we got 20. So if we look back over here, we took that 400 and we multiplied it by 0.05. So instead of writing 20, let's go back to what we did here, right? We multiplied that, we know it's giving me 20. Those are equal to each other, so that's totally legal that I can go ahead and do that. Well, now I know that Irvin is screaming because he's realizing that we have a GCF here. I have a greatest common factor. We know those factoring methods like the back of my hand. So since I have a GCF of 400, I can take both of my terms there and pull out a 400. And when I do that, that's going to leave me with 1, because that whole thing is going to become 1, plus that's going to cancel out, and it's going to leave me with 0.05. Okay? So that 400 divided by 400, that gave me that 1 there. This 400 times 0.05 divided by 400, that just left me with the 0.05. Well, I'm asking you, what single number could you have multiplied that by? I could have just multiplied 400 by 1 plus 0.5, or we already know that that's just 1. That's like really weird that I came out like that, but that's really just saying 1.05 if you add those values together. And let's prove that, okay? If I take my calculator, right, and I have 400, and I multiply that by 1.05. Whoops, I don't want to add anything. Notice you get 420. Just like before, you got 420. So you guys just did like your huge discovery for today's lesson. If you're a little confused, please go ahead and rewind the video and actually uncover what happened here. Like, how did we get this 1.05? Because this is going to be key in today's lesson. Your initial value will always change, but this growth rate, and when we get to decay rate, is going to be huge. Your last part here is saying, give an equation for the amount in the savings account, S of t, as a function of the number of years since the $400 was invested. So some of us might be overwhelmed here, but I know that Brenda is thinking in her head, like, that's just saying to us, we want to write an equation. And when they're saying S of t, like, that's a fancy way of saying f of x or g of x or w of x, which is always just a fancy way of writing y equals. So I'm going to have S of t equals. Well, how did we get like our values here? How did I get 420? This is when you guys are just going to put your full circle all together here. You started with an initial amount of $400. That is so important. Then from there, we took one number and we multiplied it by that, 1.05. The 0.05, well, that just came from my 5% there. The 1 came from because it was increasing. And now to make it into an equation, I know that I need a variable here for the number of years. Well, this is going to have an exponential function, so I know that my exponent needs to be my variable. That's where my power needs to go. And then that's your equation here. So if I said to you, like, how much money is going to be in the account after 20 years, well, I can go ahead and take 400 times 1.05 and raise that to the 20th power, and then just straight calculate that, so on and so forth. So a recall, a percentage is always a number that is out of 100, okay? So these examples here, I want you to practice making each of these numbers into a decimal. All right, so make all of those into decimals here, understanding that all of those are going to be numbers out of 100. And then let's get to this fancy, what looks extremely confusing, but I already see some smiles from like Amora and Ricky and Brittany because they know that it's not that bad here. So in general, an exponential function is increasing, which is telling me that Elisa, my base or my factor is going to be greater than 1. And since it's greater than 1, I can represent all exponential growth using this equation here. So Q of t equals Q of O times 1 plus P raised to the T. Okay, now what does that mean? What in the world does that mean? Well, Q of O, that's representing your initial value here. That's all that means. That's like your starting value. When I see P, that's representing my percentage. But I know that it must be a decimal. You must have that value converted into a decimal. The 1 is always going to stay there, and I'm adding it because I know it's an increase or it's a growth. Now, what is a general equation for decreasing of an exponential function? Well, it's going to be very similar, but one thing here is going to change. And you're absolutely right, Tammy. That only thing that's going to change, instead of adding to 1, I'm going to be subtracting because I know that my growth factor needs to be less than 1. And I'm going to write this equation different here. Okay. Oh, now I put an A here. Well, what in the world does A mean? Oh, Melissa, you're absolutely right. That does mean that that's your y-intercept. Well, another word for my y-intercept, Josh, is 1,000% your initial value. So it still means the same exact thing. That's still your initial value here. And since it's a decay or a decrease, I'm subtracting 1 minus my percentage. One minus that percentage. And Juan, you are absolutely right that this still must be a decimal. Every single time. You must make that percentage into a decimal. And these are the 2 main equations that you're going to need in order to solve these examples here. Okay? So if I wanted to know what an expression is to increase $30 by 15%, well, it's an increase. So I know my initial amount there is $30. I'm increasing, which means I need to be adding it to 1. And 15%, well, to make that into a decimal, that's just 0.15. And you can go ahead and calculate that. You could have also just wrote this as 30 times 1.15 because we know that that means the same thing. And then when you multiply those values, you're going to get $34.50. If we want to decrease a percentage, well, I want to decrease $60 by 25%. I know I need to use this formula here. So I can go ahead and take my initial value, my $60. I'm decreasing, so I need to subtract it from 1. And I'm just going to make that 25% into a decimal. And again, you could have went ahead and just wrote 60 times 0.75. And notice your base or your decay factor is 1,000% less than 1. That's a good way to check yourself. And that's going to leave you with $45. All right. I left you with a few examples to practice. Some are just setting up the equation, and some of them are actually solving for it. Okay. We'll have a Google Hangout on Wednesday to review. Have fun, enjoy, and stay great.